for Jeremiah Brewer and Kolawole Tanimojo's robotic project where we implemented a PlayStation controller to operate a robotic arm. The first part of the project was to actually build the robotic arm, as I previously mentioned in the actual project. Some of the problems that we ran into is that these are about 30 years old and the directions are very, very, very sparse. You really got to be careful about the bushings and everything else when you construct these. Some of the components look like they're going to fit together, but they need to be assembled in an exact order. So make sure that you're ready to disassemble it should you find that one of your joints isn't working exactly like you thought it was. This is, for example, this triangle here can actually be put on either side here, but it's important on which side it is so to keep the cylinder there lined up right. So make sure you pay attention to where every single piece is at. Some of these also have some bushings in them to make them actually move, like this one right here. So you need to make sure that you're assembling these plates in the right place. Another tip: I strongly recommend getting a vise to hold down the base plate as you're moving this arm. It is going to tip over once you get past certain points. And that's pretty much all the advice we have for Project 1. For Project 2, we had to build our own power supply to supply enough voltage to run everything. We have a 19 volt, 8 volt, 6 volt, 5 volt, and 3.3 volt power supply here, capable of outputting all those voltages. The motors from Project 1 required between 19 and negative 19 volts to move. That's the reason we had to have such a high voltage. Now, the power supply that we bought to attach to this is just a regular laptop power cord that we got off eBay for about $7. It'll stay with the board when we leave, so you don't have to worry about getting another one. However, should you need to, it's attached on the back right here. We're using an old hard drive connection right there that we just cut off a burned out hard drive. Now, the only problem we had with that was the fact that the laptop power cord actually pulls up to 3.5 amps, and most of our components are not rated to do that. If you create this board on your own, you will have to make note of what your components are capable of handling heat-wise. One of the things we used were these resistors right here. These are 1 watt dissipation resistors, so they are capable of reducing a lot of the amperage in a small amount of area. If you use smaller ones that only use like a 1/4 watt, you're going to have to multiply how many resistors you have by 4. We did them in parallel. Please make sure that you do your calculations correctly so you don't burn up a lot of components. Now, when we actually run it to the DC motors, we even run more because we actually want to get up to a full amp. The ones that are on the board over here are protection for the circuit above, so we don't actually burn out any of our lower rated voltage regulators. The parts list will actually be, there will be a link to it on our wiki page. On that, you will see the diagram and the schematics of how to build your own power supply, just like we did, including a parts list. On there is also the parts so you can actually build your own pick. It includes everything, including the crystal that you need for a clock rate. We ended up going with our own pick. We ended up using the Arduino Uno, and I will talk about that a little bit later in Project 3. And that's pretty much all the advice we have for Project 2. For our Project 3, I want to talk about some of the things that we ran into with our project. We chose to use an Arduino Uno board, which is this board down here. Now, this board is capable of handling up to 10 digital in-outs. Unfortunately, we have to have 12 to actually operate the motors because of the H-bridges. We need 2 in-outs per motor, one to go to 19, one to go to negative 19. Now, the way we ended up doing this was we used 6 straight from the pick to operate the relays that we have. And then we actually use a combination using the AND gates to work the other 4. Now, the way this works is, as you can see from this board right here, we actually run from A0 all the way up to A7, and then we have 2 latching ones, which are those 2 white wires that are on the pick right next to the in-outs right there. And we run those to multiple spots on the board. This right here, this one down here, and this jumble of mess down here. This one here actually runs to our AND gates. That's why it looks like a rat's nest. Now, depending on how you coded your software will determine on how you use the AND gates. But once they pass the AND gates and the ones that are coming in straight from the signals, what we do is we run those to the relays. And the reason being is because these H bridges are getting 19 volts as their enable. The signal in is actually coming from our relay, and what we want to do is we want to ground the signal. To do that, we run the board's ground right up to the relay. And we're using reed relays. So when we send a signal to the relay, it allows whatever's in the H bridge to go to ground, which will pull it one direction or the other. And then we run the outputs off the back into our parallel port. And the documentation for that is also included with Project 3, so you shouldn't have any problems wiring up the parallel port. The board gets a little bit messy. I recommend using a bigger perf board than what we used. Hindsight's 20/20, but we actually needed a lot more space than we had. One of the other issues that we had that I really want to make sure of is we had a lot of problems coding the Arduino PIC. We used some existing source code that somebody said was actually for the PlayStation True. You really need to make sure the documentation that you're using if you're going to use separate source code other than the one that we provided. The code that we have is actually for a PlayStation 1 controller. And our original intent was to use a PlayStation 2 controller, being as that's the code that we were told that we had. It turns out from one of the pictures we were able to actually see that he was using a PlayStation 1 controller and not a PlayStation 2. So regardless of where you get your code from, please check the documentation and assume it's wrong. That pretty much covers all of the wiki for our project from 1 through 3. Thank you very much, and I hope you enjoyed our project. When you're adding your AND gates, depending on how many inputs you're actually going for, there are two different kinds. There's CMOS and TTL. The TTL is only required to bump the voltage on the output up to 2.5, whereas the CMOS will actually output closer to between 4.3 and 5 volts. In order to fire the relays, 2.5 is not enough. You must use the CMOS ones. So please make sure you are using the right AND gates. The AND gates we used were 7408s. They will say AHC on the chip. Thank you very much.